For prime factorization, you have to make a tree. I split my tree into two numbers that were fairly large so that it was much quicker to get to the bottom. Then I counted up all the 2's in the tree and wrote 2 to the 4th. There was 1, 3, and the 5, so it was 2 to the 4th times 3 times 5. 351 was divisible by 9, so I got 9 and 39, and that gave me 3 cubed times 13. 231, I gave a shot to 7 because it's such an unusual number, and I got 7 times 33. That gave me 3 times 7 times 11. Greatest common factor, what I did was I made the factorization for each one of the numbers, and you can make it with a tree or however else you want it. And the greatest common factor is the biggest number that can go into all three. So because I had 2 squared in 84 and 2 squared in 140, and 2 squared was part of 2 cubed, I knew that my greatest common factor had to have 2 squared. And since all three numbers had a 7, it also had to have a 7, and when you do 2 squared times 7, you get 28. 42 used 3 and 7. 63 used 3 squared, which includes 3 times 7. And 105 had 3 times 7, so the greatest common factor was 21. In 504 and 1260, I did the same thing. I wrote the factorization for all of these, and I noticed that both of them had 2 squared in it, both of them had 3 squared, and both of them had 7, and I put that together, 2 squared times 3 squared times 7, and I got 252. Least common multiple, you have to find a number that 32 and 40 both go into. So here with the prime factorization, I took the most I could, and I took the 2 to the 5th, because that was the most 2's, and I took the 5 because that was the most 5's. And 2 to the 5th times 5 gave me 160. In 18, I took 3 squared because there were more 3's in 3 squared. There were more 2's in 2 squared, and there were more 5's here than there were here, which was none. And when I put 2 squared times 3 squared times 5 together, I got 180. I took the 5 from the 15. I took the 3 squared from here because there are more 3's in 3 squared than in plain 3. And I took the 2 squared from here because there are more 2 squareds than there are plain 2's. And when you make 2 squared times 3 squared times 5, you get 180 again. Changing decimals to fractions in lowest terms. When you have a decimal that has a finite or a limited number of numbers, like 0.12, 0.016, 0.0005, that doesn't have any bars in it, you count the number of places, and that's the number of zeros in your number. So 0.12 is out of 100, and 0.016, 3 spaces, is out of 1,000, and 4 spaces, 10,000. That's 12 out of 100. That's 16 out of 1,000 and 5 out of 10,000, and you know how to reduce by dividing by 4 over here and dividing by 8 over here and dividing by 5 over here. The trick to doing the decimals with bars, you seem to use tricks for that, and although I'm not very good at tricks, I'll do my best. When the bar covers the entire number, then the top of the fraction has those numbers, 123 over here and 12 over here, and the bottom has 9's, as many 9's as there are numbers in the bar. So if this bar is 3 spaces long, it's 999, and if this bar is only 2 spaces long, it's 99. So I put the 12 over 99 here and the 123 over 999 there, and then I reduce the fraction by dividing by 3 over here and dividing by 4 over here. No, I'm saying 3 again over here. Again, I'm not very good at tricks, but basically what I seem to figure out for here is that instead of having 99 on the bottom, you have 90 on the bottom with 1 0 at the end for the 1 bar repeat. And over here you have 99 because it's 2 places with a 0 on the end because it's a 2 bar repeat. Now where I got the 15 from was 16, take away the 1 from over here, and I got the 122 by doing 123, take away the 1 from over there. So it seems that when you have a bar that doesn't go all the way across, like this one did and this one did, you take this number and you subtract what's in front of the bar. 123, take away 1, 16, take away 1, and put it over 90 or 990, depending upon whether it's a 3-space decimal or a 2-space decimal. Just remember that the last one is a 0. I don't feel very good about this particular page because I don't do things by tricks. And if she reviewed and told you something better, then please share it with me, but that's what I came up with. In the first example where you change to decimal, where the denominator is a decimal denominator, the number of zeros in the number is the number of spaces you have. So this was 2, and because there were 5 zeros here, there were 1, 2, 3, 4, 5 spaces here. And then the 13 ends the 5 spaces with zeros filled in, and the 7 ends the 2 spaces with zeros to fill in. For the remaining problems, we take advantage of the fact that a fraction bar means divide, because you make fractions by taking something whole and dividing it up. So I did 7 divided by 8 and got 0.875. And when I did 3 divided by 11, I got 0.2727, which made me realize it was 0.27 bar, and 8 over 15 became 0.533333, which was 0.53 bar. As we've discussed all year, I think a big part of getting the right answer to a problem like this is just being organized. The typing was pretty bad because I didn't have a math typewriter when I put this onto typing paper, but this is what the example looks like when I hand wrote it. I found a common denominator for the 2 and the 5, changed 1/2 to 5/10 and 2/5 to 4/10, and that gave me 2 plus 1 is 3, and 5 plus 4 is 9/10. This problem is more difficult because when I take the 1/3 and change it to 3/9, it's too big to subtract from 2/9, so I had to borrow. The 8 became a 7, and that gave me 9/9, which added to the 2/9 I already had and made this 11/9. Then 7 take away 5 gave me 2, and 11/9 take away 3/9 gave me 8/9. Over here, I wrote the fact that I didn't have any sixths at all, just a whole 8. So again, I borrowed, and I made my 8 go down to 7, and I got 6/6 for my 1. And since I didn't have any 6 to begin with, then that's all that I had. The 2 and 1/6 could now subtract because I got change, so to speak. 7 take away 2 gives me 5, and 6 take away 1 gave me 5/6. In order to multiply with mixed numbers, you have to change 1 and 7/8 to 8 times 1 is 8 plus 7 is 15/8, and 4 over 21 is 4 over 21. Then I canceled the 15 with the 21 by dividing by 3, and the 4 and the 8 by dividing by 4, and that gave me 5 times 1 on top and 2 times 7 on the bottom, and my final answer was 5 over 14. Then 2 1/4 became 4 times 2 is 8 plus 1 is 9/4, divided by 12 ones, flipped to times 1 over 12, and again I was able to cancel the 9 with the 12 by dividing by 3. That gave me 3 and 4, and that was 3 times 1 is 3, and 4 times 4 is 16. Here I did decimal division, and in order to divide, I had to move the decimal point to 2 places, and that gave me a whole 3 divided into a whole 750, and that gave me 250. In number 28, I'm going to do subtraction, so I lined up the decimal places, and again I had to borrow, and this is simple subtraction. The trick is to line up the decimal points when you're doing addition or subtraction, and to add the 0 so you have something to borrow from. You can't just ignore the fact that this is an empty space and bring down the 2. The 2 has to subtract from something, so make sure you add a 0. In number 29, all I had to do was multiply 2 times 3 is 6 and make sure that I had enough decimal places for 1 here plus 2 here gave me 3 in my final answer. And as always, the 6 goes on the end and the zeros are the filler to make a total of 3 spaces that I need. Number 30 starts order of operations. In order of operations, the first thing I did was the multiplication. 6 times 0.3 was 1.8. Then I had to go back to the beginning of the problem and add. So 0.7 and 1.8 gave me 2.5. Take away 1 was 1.5. Again, order of operations in 31. I had to do 8 divided by 2 because it was at the beginning of the problem and division comes before addition. Then over here, before I could do the division, I had to do the exponent because exponents come before division. So I had to do 3 squared was 9, and then 36 divided by 9. Then I took the 4 I had already made, and the 4 that came from 36 divided by 9, I did addition last and got 8. Again, over here, this is a very tricky problem, number 32, because people always want to multiply first, even though division is first in order. First, you have to do 12 divided by 2 and get 6. 6 times 3 is 18, and last comes plus 4. Remember, division and multiplication are in the same family. Whichever one comes first, meaning on the left, goes first. And if multiplication comes after division, then division happens first and multiplication happens later. The only thing that can take precedence is parentheses. I had to do 2 plus 1 was 3. Then I went and did the division, and last came the subtraction. Continuing with order of operations, exponents come first, so first I did 5 squared is 25, and then I went and did 2 times 25, and that gave me 50. The difference here is that here 2 times 5 makes 10, because of the parentheses before the squaring happens. Over here, you're not allowed to do 2 times 5 first because exponents are attached to the 5 and no parentheses brings the 2 into the picture. 2 is a multiplier, exponents go first, and then the 2 multiplies the answer to 5 squared. Over here again, order of operations says I have to do -6 with +7, that gave me -1, and then the -4 and the -1 make -5. If you want to change this to plus -4, you can. That's entirely up to you. Over here, the parentheses came first, so -9 plus 1 made -8, but in front of the -8 was a minus sign, so that made 7 minus -8 became 7 plus 8, and that's why the answer is 15. I hope I'm not making any mistakes, Jack, because I'm making this very late at night, and it looks like it's all good to me, but when we speak together, you'll find any mistakes I made, and you'll point them out to me. Getting on to number 38, again, multiplication comes before the -8 subtraction part. So this times this is 12. It's take away 12. So I have -8 take away 12. And I just look at that as I have a -8 and I have a -12. So I have a -20. And again, if you want to change this to plus -12 before you add them, that's perfectly fine. Over here, I did -5 times -2. That made +10. I skipped the plus sign because it's later in the order of operations. All these multiplications can be done together, and that gave me -24 times 2 is -48. So I had to add a +10 to a -48, which is why I did subtraction, because one's negative and one's positive. So -48 with 10, the difference is 38, and it's negative because I had more minuses than pluses. -38. Number 40, I did 8 times 5 is 40 first, skipped the subtraction and figured out what -2 times 1 was. That gave me a negative from here and a subtraction from here. Minus minus makes a plus. So again, you can just change this to plus if you want to, and 40 plus 2 is 42. Over here, negative 5 squared means negative 5 times a second negative 5, and the two minus signs cancel out, and the answer is positive. 42 is again a trick question. It wouldn't surprise me if she puts it on your final, so watch out. The exponent is only on the 5. The minus sign is in the subtraction family, and it waits till the end. 5 squared makes 25, and then the minus jumps on and makes minus 25. Look at the difference between these two problems. They are not the same, and this is a trick question that all math teachers like to use. Negative 2 means a reciprocal exponent. It means do 5 squared is 25, and then move it from the top, so to speak, to the bottom. There's an invisible fraction bar underneath here, and when the negative exponent gets activated, the 5 squared moves from being up here to going down here, and we put 1 as a placeholder, which is why the final answer was this. Typing's pretty lame, but this is 2/5 divided by 1/3. And again, we're going to use the fact that the fraction bar means division. You can use that option anytime it fits, like changing a fraction into a decimal. You use the fact that a fraction bar means divide, and do the top number divided by the bottom number decimal style. But here I don't need a decimal, so I'm going to write 2/5 divided by is the fraction bar, 1/3 is the bottom, the denominator. Then division switches to multiplication of the reciprocal, and now I have 6 over 5 gives me 6/5. Again, over here, whenever you have a fraction bar in a problem and the problem looks weird to you, just switch it to division. Take the 6 and rewrite it. Take the fraction bar and write division. Take the 3/5 and write it after the division. Then all you have to do is flip the division to multiplication. The 3/5 becomes 5 over 3. Now the 3 on the bottom can cancel with the 6 on the top, and my final answer is actually 10 over 1, but it's usually not written when the 1 is on the bottom. If you wanted to, you could have written 10 over 1, but most people don't. Here was a substitution, so I did 4 times 5 for R and 9 times 2 for M, and I got 20 and 18, and the multiplication came before the addition, and I got 38. Again, this is the same trick over and over again. The squared is only on the R. There's no parentheses that brings the M into it. So since R was 5, I did 5 squared is 25, and M equals 2, waited till the end to multiply the 25 that 5 squared made. N take away B was just 6 take away 4, and that was 2. Here I did R times N. That gave me 30. Then I did take away minus 3. And again, minus made a plus. Minus made a plus. So the top became 33. The bottom became 11. And 33 divided by 11 is 3. Number 47, I did R times M, which was 5 times 2 is 10. And then I skipped the subtraction because in order of operations, multiplications come before subtractions. So I jumped over here and did M times N, which was 2 times 6 is 12. And then 10 take away 12 is negative 2. A positive 10 and a negative 12. You subtract because the signs are different and use the sign that there's more of. Or as always, you can change this to plus minus 12 if it makes you feel better and get negative 2 that way. A times N was negative 3 times 6 was negative 18. Because it was in parentheses, I did it first, and then I squared it. And whenever you square a negative number times a second negative number, your answer is positive. Over here, again, M was 2. A times B comes next. The subtraction waits for later. A times B was negative 12. So I had this double negative again in the middle of the problem. And minus minus makes a plus, and 2 plus 12 is 14. Because of the typing, the 3/5 looks really weird here, but whenever you have a fraction, an equation, with a fraction in it, the easiest thing to do is to get rid of the fraction. Now, could you have done minus 3 before you multiplied by 5? Yes. Why did I decide to do the 5 first? I have absolutely no idea. But I did 3/5 n times 5, and that gave me the 3 in the n without the 5. And then I had to do 3 times 5 is 15, and 15 times 5 is 75. If you're going to multiply an equation that has 3 parts by 5, it has to be 1, 2, all 3. Then I subtracted 15 and got 3n equals 60, divided by 3 and got n equals 20. Over here, I had to move the minus 3y to this side because I like variables on the left. So I got 4y over here. Then I did take away 10 and take away 10 so that the 24 was over here. Make a plan. If you decide that you want to keep the y on the left, then the y on the right doesn't belong. Subtract it. If you decide that you want the y's on the left, that means the numbers go on the right, and that means that this 10 doesn't belong, so subtract it. Over here, the difference between 57, which I guess I shouldn't have done first, and 55 that kids mix up is that this 3c and this 7c are together on the same side of the equation. You don't have to do anything to put them together because they're already together. This 7c and this 3c make 10c, whereas this 7y on the left and this 3y on the right made 4y on the left because they weren't together. The 5 sort of got out of the way so that 3c wouldn't mow it down when it went to join mama. And now that the c's are on the left, the 5 doesn't belong, so I subtracted 5 from both sides. I had negative 35 and negative 5 made negative 40. Divided by 10 gave me negative 4. Jumping over, I guess I should go to 56 next. I distributed the 5. That gave me 15m plus 5 equals 65. Since I like m on the left, I did minus 5 minus 5. That gave me 60. And divided by 15, I think I have to move the page. There's my m equals 4. I guess continuing right along, this one's a little complicated, but we always get rid of parentheses first. So I distributed the negative 4. That gave me negative 8n and positive 20. And the minus 6n just sort of sitting there waiting for the distributing to be finished. It's on the left with negative 8n. So they're going to join up without any extra algebra being necessary. Then I had 3n minus 12 with the minus 2 on the end waiting for the distributing to be done. And again, since the negative 12 and the negative 2 are together on the same side, they don't have to do anything special to make negative 14 together. So I had negative 14n from here and here, plus 20 equals 3n minus 14. And then again, because I like my variables on the left, you could do whatever you want. It's not wrong to plus 14 here. I minus 3n here and got negative 17n. Then I took away 20 minus 20 minus 20. That gave me negative 34. And when I divided, I got n equals 2. You could have done the exact same thing by moving this to the right and this to the left. You would have had positives instead of negatives, but you would have still had n equals 2. I think we already did the one at the top, but I'm going to check. Yep, we're ready for number 58. Here I cross-multiplied. Why did I do 8 times x minus 1 first and put it over here? I have absolutely no idea. I was in the mood to do it this way, so I did. As long as you do the right 2 together and the correct 2 together, I didn't mean right as in right and left. I meant right as in correct. it's equals, so it doesn't matter which is which. I had 8x minus 8 equals 6x plus 2. Don't forget, be careless. If you multiply 3x by 2, you also have to multiply 1 by 2. The same way it was 8x minus 8. Don't forget that. It's both together. Then I minus the 6x and got 2x. I plus 8 and got 10, which gave me x equals 5. Here I decided to get rid of the parentheses by distributing before I cross-multiplied. So I got 2b minus 10 over 5 equals b plus 7 over 10. And yes, Jack, we already talked about the fact that you can do cancellation like this across an equal sign, but because I wasn't sure what you were in the mood for, I did it the old-fashioned way. And here, interestingly enough, I did 10 times 2b minus 10 first, and then did this later. It doesn't make any difference. So I got 10 times 2b was 20b minus 100, and then I got 5b plus 35. I minused the 5b from both sides, and I plussed 100 to both sides, and that gave me b equals 9 when I divided by 15. I hope you realize that you can pause this anytime you want and come back to it later, or go back and rewind it and see something again. I'm talking relatively quickly because you don't have to hear me say anything twice. You can just go back and replay it. The difference between inequalities happens when you divide by a negative number. So the first thing I did is exactly what I would have done if it was an equation. I added 5 to both sides so that all my numbers were on the right. But now when I divide by negative 2, I end up with n is less than negative 6, when it used to be greater than, because when you divide by a negative, the inequality changes. And since I wanted numbers that were lower than negative 6, I put a circle around negative 6 and I shaded lower. And I made it an open circle because there's no equal sign over here. In number 62, there is a greater than or equal to sign. So again, I subtracted 6 on both sides, but subtraction doesn't change the inequality. When I divided by 3, since 3 was positive, again, nothing changed in the inequality. So now I want numbers that are bigger than or equal to negative 1. So I put negative 1 on the number line, shaded numbers that were bigger, and filled in the circle to show that equals for negative 1 was okay. Number 63 uses the fact that we have a fraction in an equation. So the first thing I did was I did times 3 over here and times 3 over here. And because 3 was positive, the inequality didn't change. So I still have my negative 2. I still have my y. My 3's canceled out. I still have my greater than. Negative 12 times 3 is negative 36. But now when I divide by a negative number, the inequality is going to change to y is less than. Negative 36 divided by negative 2 is 18. So again, it's an open circle on the 18. I want numbers that are lower than 18, which are numbers that are down here, and that's what the graph looks like. Moving right along, the next thing you want to do is change things to percents. So one thing you can do is you can say that 3 over 8 is what percent out of 100, and set it up as a ratio. I cross-multiplied and I divided, and I got that P was 37.5, and 37.5 was a percent. I did the same thing for 5 over 12 and said that 5 over 12 is what out of 100, because what is the percent. And then I did my division, and when I ran out of numbers, rather than making a decimal, I took my remainder of 2 and made, it wasn't 2 actually, the remainder was 4 out of 12, 8 out of 12, I'm sorry, and that became 2/3. So it became 41 and 2/3%. Over here, I took advantage of a decimal shortcut that I'm sure Mrs. Goldfarb taught you, and that is that if you want to change a decimal to a fraction, you have to move the decimal point 2 places to the right, and it becomes 4.5%. If you're ever a little nervous about using that, you can always take advantage of the fact that .045 is 45 over 1,000, and you can equal that to P over 100. And when you solve this ratio, you end up with 4.5% that way. But if you learn the decimal shortcut, it's always a good idea. If you remember that percent means out of 100, if you have a simple percent like 4%, it's just 4 out of 100, and then divided by 4, I get 1 out of 25. If it's a half a percent, you can put a half out of 100, and then you can basically take advantage of this option that you had before, which is that a fraction bar means divide. So what you could do if you wanted to is write 1/2 divided by 100, which becomes 1/2 times 1 over 100, which is where 1 over 200 came from. Over here, I put 5 2/3 over 100, and again, because it looked weird to me, I took advantage of my division option and changed 5 2/3 to 17/3, and divide the fraction bar to divided by, and 100 to 100 over 1. The division switched to multiplication, and the 100 over 1 flipped to 1 over 100, and that gave me 17 over 300, which is what 5 2/3% is. We're getting to the algebra problem, which are not your favorite, but I'm giving you the answers anyway so that you can look it over. When two numbers differ by a certain amount, that 62 is how they're different. It means that one is bigger and one is smaller. So I always like to make x the smaller number, add 62 to the smaller number, and get the bigger number, which differs. The difference between these two numbers is that this has 62 more, which is what it says. Then it says the larger number is, so I wrote the larger number is 4 times the smaller number, 2 more. Whatever comes at the end of the sentence goes first, and whatever comes in the front goes last. So I got this equation. You have the answer key and you can pause it. I think if I talk about it anymore, it'll probably just make everybody crazy. But I did the same thing I always do with moving things around. In number 71, I had 135 jelly beans, but first I had to set up the problem. So since it said twice as many yellow as orange, and orange came at the end of the phrase, orange got to be x, and twice as many meant that yellow was 2x. Then I moved to the second phrase, and it said green was 5 more than orange. And again, because orange was at the end of the sentence, I made green from orange by adding 5. Since orange was x, green was x plus 5 more. And again, in the last phrase, they mention green later. That means I'm going to make red from green. If green is x plus 5 and you make red by doing twice, I did 2 times x plus 5. Now all I had to do was add up all these formulas to 135, which was the total number of jelly beans, and I used the distributive law over here, so I said x, 2x, x plus 5, 2x plus 10 equals 135, and I ended up with 20 orange, double is 40 yellow, 5 more green was 25, and double was red. The last word problem is a ratio word problem. It says that if you use this much flour with this much sugar, how much flour will you need for this much sugar? And the implication is that it's proportional or at the same rate. There has to be some way that you sort of feel that this is a ratio problem. So I put 8 for flour on top of 10 for sugar, and again I could have done it the other way around. I just had to make sure that if flour was on top, it was on top over here, and since it said how much flour, I made it x for 35 sugar. And again, there's a lot of reducing that you could have done because of the equal sign. 8 and 10 can always reduce when they're in the same fraction together across an equal sign, bottom to bottom. But again, because I wasn't sure what you were in the mood for, I just did it the old-fashioned way. 10x equals 8 times 35 is 280, and that was 28 cups of flour. The rest of the review sheet is the way she wrote it for two reasons. Number one, you haven't written on this page yet, and for number two, we did almost all of it together when we met. So this video is way longer than I'd like it to be anyway. The only reason it's tolerable is because you can stop it, pause it, come back to it later, rewind it, do whatever you want to it. So I included this just so that you'd have it, but there's no more talking going on here from here until the end. So I hope this helped you, Jack, and I'll see you or speak to you soon.